This week we're going to be looking at series. So we need to determine the convergence or divergence of the sum from n equals 1 to infinity of 2n squared times root n over 7n cubed plus n plus 3. So we can notice that this series is going to be less than the series of 2n squared root n over 7n cubed, because a larger denominator makes this smaller. And this is just like 2n to the 5/2 over 7n to the 6/2. So this is going to be the same as 2/7 times 1 over n to the 1/2. So we may think that we want to use the comparison test. So if we look at the comparison test, it says that we have a series greater than 0, and then we have another series that's greater than that. And it says that if an diverges, then we know that bn diverges. And if bn converges, then we know that an converges. But if we look at this series up here, we know that 1 over n squared diverges by the p-test. So we have that our bn diverges, but we can't figure out anything about a from that, which means we can't use the comparison test. So then we go and we say, oh, well, maybe it's the limit comparison test. Usually if you think you can use the comparison test and you can't, then limit comparison test is going to work. We don't want to use this one. So, in the limit comparison test, we take the limit as n goes to infinity of an over bn. So we're going to have the limit. An is our original series, which is 2n squared root n over 7n cubed. And then we would be dividing by pn, but we can flip and multiply. So we're going to have 2/7. So immediately we can cancel these 2's. And then we're really just going to look at what we can simplify. So we have this n to the 1/2, we have another n to the 1/2, and we have an n squared. So this can be rewritten as 7n cubed over 7n cubed plus n plus 3. We just combined all of these exponents. So then, if we multiply top and bottom by 1 over n cubed, then we get the limit as n goes to infinity of 7 over 7 plus 1 over n squared plus 3 over n cubed. So, now we can take this limit. 1 over n squared and 3 over n cubed are both going to go to 0, and we're just going to have 7 over 7, which is equal to 1. So now the limit comparison test says that if we get this to be greater, this is our L, our limit. So if L is greater than 0, then either both converge or both diverge. And then we look at Bn to figure out which one that is. So we know that Bn, remember, is 2/7 1 over n to the 1/2, which we know by C-series diverges, which is what we already talked about. So since either both diverge or both converge, we know that we now know that our original an series, n equals 1 to infinity of 2n squared root n over 7n cubed plus n plus 3 is also going to diverge by the limit comparison test.